given w is the square root of 5, x is the square root of 7, y is the square root of 4, and z is the square root of 9, which expression results in a rational number? So we have to know what a rational number is, okay? And we have four choices: w plus x, y plus z, x plus y, or w plus z. All right? Now, real numbers are made of what we call rational numbers and those that are not rational, okay? And they give you some examples of irrationals. But now let's look at rationals a minute. Rationals are made up of integers, and integers could be either the positive integers or 0 or the negative integers. And then we throw in all of the fractions here, the numbers that are not integers but they are fractions. Those are rational numbers that are not integers. So we throw in the integers and the rational numbers together. We call that rational numbers. All right? Throw in the integers and the ones that are the rational numbers that are not integers all together. We call them rational numbers. Then we have irrational numbers. So let's talk a minute about natural numbers. That would be this positive integers thing here. Okay, that's called the natural numbers. And that's the number like 1, 2, 3, 4, 5, 6. And then if you throw in the 0 in here, if you start off with the 0 along with the 1, 2, 3, 4, 5, 6, you have what we call the whole numbers. Now the integers are not only 0, 1, 2, 3, 4, 5, 6, but also the integers go negatively. Okay, notice I don't have any fractions in here yet. Okay, now the fractions are what we call ratio numbers or rational numbers. Those are called fractions. All right, here's a fraction, another fraction. -3 can be written as a fraction. Okay, 0 can be written as 0 over 1. -3 could be -3 over 1. I could call this 7. These are all rational numbers. There's another fraction. This is a decimal, which is another word for a decimal is called a decimal fraction. Okay, and so 17 hundredths minus 17 hundredths and 10 and a half. Now, -2.7 is a rational number. You're going 1, 2, not quite to 3, -2.7. These are all rational numbers. -3 halves, 1 half, 2 halves, 3 halves. 0 is a rational number. What's this number? This is plus 3 halves, isn't it? 1 half, 2 halves, 3 halves, which can be written as a decimal. And here's another rational number, 4. 4 can be written as 4 over 1. So these are all rational numbers, all right? Now, rational numbers, each rational number can be expressed in either terminating or repeating decimal notation. Okay, let me show you what I mean. 0 can be written this way. Okay, it's a rational number. This is a rational number. This can be written as -8.75. So these are the same thing, and they are both rational numbers. Okay, 0 can be written as 0.0 if you wanted to write it as a decimal. This can be written as 0.27. So these are both rational numbers. If you divide 13 by 6, it's going to go 2 times, and you're going to have 2.16666666666. So the fact that this repeats makes it a rational number. Okay? The 6 repeats forever, so we don't write all the 6's out there. We just put a line over the 6. This is a rational number because this is a decimal that terminates or it repeats with a 6. Terminates up here means 875 and you're finished. All right. Every rational number, you can put it on a number line. There are some points on the number line that are not rational. Okay? Some points on a number line that are not rational. We call them irrationals. If they're not rational, they're irrationals. And what kinds of numbers are irrational? One of them is pi. And you use that like if you're doing pi r squared, that's the area of a circle. If you say 2 times pi times r, that's the circumference of a circle. So pi is irrational. Okay? If you write that out, 3.14 is not really pi. 3.14159 is not really pi. It's an estimation of pi. Pi never repeats. It goes on and on and on and on and on as a decimal. Another one is the square root of 2, written this way. Okay, if you have a square and the length of one of these sides is 1, and 1 for this side, Pythagorean theorem says that c squared, or the hypotenuse squared, equals a squared plus b squared, where a squared is 1 and b squared is 1 squared, and 1 times 1 is 1, and 1 times 1 is 1, so c squared is 1 plus 1, which is 2. So this side squared, if you take the length of this side, we call it c, and you square it, you'll get 2. So c is the square root of 2. Okay, so exactly how long is the square root of 2, which is this side? How long is this side? Well, square root of 2, if you square that, you're going to get exactly 2. That's c squared is 2. Okay, but what is the square root of 2 thing here? 1.4 is pretty close to 2. Why? Because 1.4 times 1.4 is almost 2. Okay? 1.41 is closer because 1.41 times 1.41 is almost 2. In fact, it's closer than this one. Okay, this is closer to 2 than this one is. You could say 1.414 times 1.414 is really close to 2. Okay? Alright, you see what I'm saying? This is never going to repeat. It's going to go on and on and on. Square root of 2 is 1.414, and on and on and on and on and on, because it never repeats. Alright? So, it doesn't repeat, and it doesn't terminate. Okay? Neither terminates, nor does it repeat. Rational numbers, you can write it like 0.75 or 2.166666666. That makes a rational number. Numbers like 1.414 ... never repeats are irrational. So square root of 2 is irrational. You got the square root of 3 is irrational. Square root of 8 is irrational. Square root of 11 is irrational. This is 1.12. It looks like it repeats, doesn't it? But it doesn't. It goes 1, 2, 1, 2, 2, 1, 2, 2, 2, 1, and then 4 2s, 1, and then 5 2s, 1, and then 6 2s. So you can never finish writing it. It never repeats. This is irrational. So these are 4 irrationals. Okay. This is rational. This is rational. This is rational. That's rational. That's rational. But this one is not. 1.414 something. And 3.14159 for pi, it's irrational. It never repeats. So you have these along with these on the number line. Okay? Now, go back to our question here. Which expression results in a rational number? Let's look at the first one here. Let's look at w plus x. Now, w is square root of 5, which is irrational. Okay? Never repeats. If you add the square root of x to it here, that never repeats. You can write it as a decimal. It never repeats. It never terminates. This is going to be irrational. Okay? When you add 2 irrationals, you get something that never repeats. Alright? Irrational. So we got to cross this off our list here. Let's look at y plus z. Y is this one and z is this one. Let's look at y plus z. That's the square root of 4, which is what? What's the square root of 4? 2. Square root of 9 is z. Okay, so that's going to be 2 plus 3, which is 5, and that's a rational number. You can write 5 as a fraction, 5 over 1. This is our answer. Of our 4 choices, we're going to pick B. Well, what's wrong with answer C, x plus y? Let's do that, x plus y. X is the square root of 7. Y is square root of 4. That's 7, square root of 7 plus 2. 7, square root of 7 is irrational. That makes this irrational. That's what's wrong with answer C. Answer D, w plus z. We got w, which is the square root of 5, right? Z is the square root of 9. So you have the square root of 5 plus, what's the square root of 9? 3. This is going to be irrational because of the square root of 5. So of my 4 choices, we eliminate A, C, and D. We pick answer B. That's the one that's what? Rational. It is a rational number. 5 is a rational number. 2 plus 3, the square root of 4 plus the square root of 9, 2 plus 3 is 5. Answer B.